So I think we can maybe get going. I see there's more people coming online as we speak, but good morning or good afternoon, wherever your time zone may see you today. My name's Claire Hobby from TCO Development, and welcome to our first webinar of our 2016 Sustainable IT webinar series. We're really glad you could join us today, and we look forward to you joining us for each of our webinars in our series this year. We'll take the opportunity to look at some hot topics and best practices in sustainable IT. We'll be looking at some trends. We'll be sharing expert knowledge from the field, from purchasing and from research and legislation, voluntary initiatives, for example, and really give particularly you as purchasers some very practical tools and guidance that you can hopefully use in your sustainable purchasing efforts. Today we're going to take a look a little bit more closely at toxics in IT products. We're going to be taking a closer look today at toxics in IT products when we've got two great speakers with us today. So firstly, before we get going, I just wanted to introduce you to TCO Development and TCO Certified if you're not already familiar with us. For over 20 years, we've been certifying IT products, so computers, displays, IT hardware, for various sustainability aspects. Today, we've grown to become the most comprehensive sustainability certification exclusively for IT products. And we include environmental criteria, social responsibility criteria, also ergonomic and usability criteria throughout the product life cycle, so from manufacturing all the way through to end-of-life handling. As part of TCO Certified, all the product models we certify and their final manufacturing plants are third-party verified for compliance with all our criteria. And as many of you may know, last November we've launched our latest generation of TCO Certified, which we do typically every 3 years. And among the new criteria and enhanced criteria in this new version are a new approach to phasing out hazardous chemical substances in the IT products we certify, and also an enhanced follow-up of our socially responsible manufacturing criteria, looking more closely at how positive change is implemented at the factory level. Just a little note about our webinar series this year. We'll be looking at a number of different topics, and many of you know we sent out a brief survey a couple of weeks back looking at what kinds of issues are purchasers really interested in knowing more about, what kind of guidance do you need. And thank you to those of you who responded to that. We got some great answers and input into helping us design content for our series this year. So some of the topics that you've requested and that we think we can share some good information about are definitely sustainable IT purchasing, environmental and social criteria, also verification. How do we know that the products we buy actually live up to the criteria that we set? And also taking a look a little bit later on this year at some longer-term sustainability trends. Where are we heading with voluntary initiatives? Where are we heading with making sustainability improvements when it comes to our IT infrastructure? So our next webinar is scheduled for March. We're still working on a date, so we will get back to you hopefully sometime next week and confirm the date for our next webinar. Looking a little bit closer at today's agenda, again, we're looking at toxics in IT products. This is really a hot topic right now. We're all fairly aware, I think, of initiatives such as ROS and REACH, who've done a certain amount of work in reducing some of the toxic elements in our IT products, things like heavy metals and halogenated flame retardants. But there are so many chemical substances in our day-to-day lives right now, not only IT products. I think the number is 70,000 chemical substances and even more. And a very small percentage of those substances have been tested for any kind of health and environmental effects. So we really know very little about the chemical substances that are around us today. So while many of these substances have been phased out from our computer products, we need to know what's replaced them in a function such as flame retardant. have those substances been tested? What do we know about their long-term effects? So the purpose of today's webinar is really to give an overview of what's the situation in our world today as far as chemicals are concerned, what legislation is in place, what kinds of voluntary initiatives are in place, and what kind of effect are they likely to have. And we also definitely want to look at how you as a purchaser can contribute to the continued reduction and phase out of hazardous substances in the products that we buy. We'll also be looking, of course, at an overview of the new chemical criteria in the new generation TCO certified. On to our speakers. Before we get going, we have two speakers with us today. Our guest speaker is Dr. Marlene Ågerstrand from the Department of Environmental Science and Analytical Chemistry at Stockholm University in Sweden. Dr. Ågerstrand's research focuses on identifying deficiencies in the environmental regulation of chemicals and suggesting workable solutions. Our second speaker is Nicholas Riedel from TCO Development. Nicholas is responsible for the criteria development and the overall program for TCO Certified, including the latest generation that was launched last November. He has particular background in the quality testing of IT products and as well as the development of international standards in usability and sustainability. So with that, again, thanks for joining us, and I will now hand over to Marlene. Marlene, welcome.
Thank you. Okay, so thank you for the introduction. The aim of this talk is to give an overview of how chemicals are assessed and managed, and also to show some examples of the complexity of this process. And my presentation will center around 4 different questions. And I will start by talking about how many chemicals that we actually have on the European market and what we know about them. And we see a dramatic increase in the use of chemicals, 60 times in the last 60 years. And after the registrations in REACH are completed in 2018, we will probably end up with 30 or 50,000 substances on the European market that is used on a regular basis. And globally, I think we have many more. And this number includes pharmaceuticals, plant protection products, biocides, industrial chemicals, cosmetic substances, and food additives. So when considering environmental and health effects from chemicals, it's important to apply a life cycle perspective. So emissions can originate from production, they can originate from use of chemicals or use of products that contain chemicals, and from waste. And I think several of the legislations that we have in Europe do not consider all these different phases in an appropriate way. So sometimes we underestimate the risk. Given the increasing population, the improved living standards that we have in our parts of the world, and the life cycle changes that we see in society today, we expect that the use of chemicals will continue to increase. And therefore, of course, it's very important to use chemicals that we think is safe, and also use them in a safe way. So what do we know about the chemicals that we use today? Well, some of the chemicals are well investigated, but for the absolute majority of the chemicals we know far too little. But we continue to use them every day. And this strategy is not something that we use in other areas. For example, when we pick mushrooms in the West, we only eat the mushrooms that we know are okay, just because we know that are poisonous mushrooms out there. So, but when it comes to chemicals, we continue to use the problematic substances, and we continue using the substances that we don't know anything about. And the reason why we know so little about the majority of the chemicals on the market is that the regulatory framework has been lagging behind for a long time. We have strong lobbying from the chemical sector, and also I think chemicals have not been a topic of interest for a broader public. And hopefully, I think this is starting to change, and we also see that some of the non-legislative measures, like voluntary initiatives, can help to speed up this process of generating new knowledge and substituting hazardous chemicals. So the short answer to the first question is that we use a lot of chemicals and we don't know enough about the majority of them. So the second thing I would like to talk about is how we assess chemicals. So I would like to give you a crash course in how to hazard assess a chemical. When we do that, we look at three intrinsic properties of a substance, the first being bioaccumulation. So many of the problematic chemicals that we see in our bodies and that we see in nature, they are fat soluble, which means that there will be a greater concentration of a chemical in a fish compared to the surrounding environment, the surrounding water. And also that concentration usually increases the higher up the food chain you go. So the shark to the left in this picture will probably contain more fat-soluble chemicals than the algae to the right. So then you can think about where you are in this food chain. Like, do you eat vegetables or do you eat meat? One example when this became a problem was in the 1960s, 1970s, when the concentrations of PCB in seals in the Baltic Sea increased to toxic levels, and the seals had difficulties in reproducing. And luckily, PCB was forbidden on a global scale, and the population has recovered. So that's a successful story here from that was a joint effort from many countries. But today we still find PCB in our bodies, and this has to do with the second aspect that we should consider when we perform a hazard assessment, and that aspect is persistence. And persistence is a chemical's resistance to degradation. So if a chemical is not degraded or degrades slowly, the concentrations in our bodies and in the environment will increase if we continue to use it. One example of this comes from the Arctic region, where PFOS, a perfluorinated substance, have been found in polar bears. And this substance is not manufactured in this area, so it has been transported there via air or ocean currents. And this is what happens to persistent chemicals like PFOS. And the figure to the left is a prediction of the expected concentrations if we stop using perfluorinated substances now. So I don't know, can you see my mouse? I hope so. So the bars represent the emissions. So if we stop using these substances, we will stop emitting them to the environment. And the black line represents the concentrations that we expect to find in the environment. So even though we stop using the substance, the concentration will continue to be quite high for a long time. And the dotted line represents the concentrations in the Arctic region. And as you can see, this curve doesn't bend, and that's because the temperature and the days are so short. The temperatures are so low, and the days are so short in this region, so the degradation is even slower in these areas. So even though we stop using these substances here, we will have them for many years. So that's the reason why we need to stop using persistent substances. And the third aspect that we need to consider in a hazard assessment is toxicity. And there's a wide range of different aspects that can be investigated here. And the worst type of toxicity, the worst type of toxic substances are those that are carcinogenic, mutagenic, and reproduction disturbing, or have some similar effect to that. And those substances are within the European Union called substances of very high concern. And if you are familiar with, or if you read documents from government, you will sooner or later bump into these abbreviations. So substances of very, very high concerns, PBT substances, that is persistent bioaccumulative and toxic substances, or CMR substances, that's carcinogenic, mutagenic, or reproduction disturbing substances. And we also have the aspect called endocrine disrupting chemicals. It's a new thing that, or it's not really a new thing, but it's something that we're discussing a lot these days. And those are also important as chemicals to keep in mind. I just want to say that all hazardous chemicals does not constitute a risk. So you can have a very problematic substance if you manage it really well and make sure that there are no emissions from, for example, a production facility and so on. But in real life, it has been proven to be very difficult to really control the exposure of a substance. So the conclusion to the second question is that we look at the bioaccumulation, persistence, and toxicity of a substance when we assess if it's hazardous or not. And the third question is very interesting. Why do we still use potentially hazardous chemicals? And the answer to this is not straightforward, but I will try to give you at least some examples of the complexity in the regulation of chemicals. And these diagrams show the increase in hormone-related breast and testicular cancer in European countries over time. And the diagrams comes from the UNEP report that came in 2013. And it concludes that factors such as diet, lifestyle, and the aging population cannot explain this increase in these type of cancers, and endocrine disrupting chemical is a suspected contributing factor. We observe these kinds of trends both in wildlife and human population, and with that we can say that the legislation so far has not been protective enough for the human health and the environment. So I would like to give you some examples of the limitations of the current legislation. So for example, the current testing requirements are insufficient. And this table here shows you shows when a particular test is needed. So for substances below 1 ton, no tests are needed. You can see it here. And for example, PFOS, the substance that we could see in the polar bears, it was produced below 1 ton. So for a substance like that, no test would have been needed according to the current legislation, which is of course a problem. So, and for substances that are produced over 10 tons, there are some tests requirements. You can see here the green boxes. But the important tests, like tests that makes it possible for us to establish if a substance is carcinogenic or reproductive toxic, only apply to the substances that are produced in high amounts, over 100 or over 1,000 tons per year, and that's a lot. So in today's society, we are treating untested substances as harmless substances, and we are lack of exposure data as there are no exposure. And this is unfortunate because it's probably not true. So we need robust knowledge about all the substances that we are using today in society. Next aspect that I would like to focus on is that we assess chemicals one at a time. But this is not how we or the environment are exposed to chemicals. More likely, we are exposed to several hundreds or maybe thousands of chemicals every day. And this is sometimes called the cocktail effect. And this figure shows the effect of 8 different substances here. Individually, the effects from these substances are insignificant. The bars are really low. But the black bar show the effect of the mixture of the 8 substances. And as you can see, the effect is much larger than the combined effect of the 8 individual substances. So this phenomena is called something from nothing. So in future assessments of chemicals, we need to consider mixture effects to a larger degree to ensure that we are protecting human health and the environment. Today it's not possible to pick up a consumer product like a toy or a t-shirt and read the content declaration of that product. It makes it very difficult for the consumer to understand which chemicals that they are exposed to and also to make active choices. And the regulation of chemicals in imported consumer product is not sufficient. So chemicals that are not used in products produced within the European Union are used in products that we import from other parts of the world, for example in textiles. And China is being the most problematic country here at the moment. And the chemical producing and importing industry is responsible for assessing their own chemicals. So there's a possibility for a conflict of interest here. And the European Chemical Agency will only evaluate 5% of the assessments performed within the REACH legislation. So they will not really control all the assessments performed by the chemical industry. And the first report from the evaluation process show that industry are non-compliant in many cases, and this is of course problematic if you want to ensure protection of the environment and human health, but also it's a problem for the credibility of the system. And regulation of chemicals has proven to be a very slow process, and I will illustrate that with the example of bisphenol A. I think maybe many of you might have heard of that because it's been discussed a lot in media. So bisphenol A is a plasticizer used in many of the products that we use every day. And the risk of bisphenol A is an interesting example of the complexity of an assessment. There's a lot of aspects that different experts disagree on. For example, which studies should we include and exclude from an assessment? What is the quality and the relevance of a particular study? How much weight should we put on a particular study when concluding on the results from an assessment? And BPA belongs to a chemical group called bisphenols, and these substances are similar in structure, and they might also have similar properties, but we don't know that because the majority of the other substances are not investigated. So it took 10 years from the first assessment of bisphenol A until we saw the first risk reduction measures. So 10 years. The substance is still used in many products, but some companies have started using bisphenol S instead, which is this substance. And this substance is not regulated at the moment. So the available studies for bisphenol S indicate that the substance have similar properties as bisphenol A? If it does, will it then take another 10 years for the assessment of this substance until we see the first risk reduction measures? I hope not, but that is how the process looks like at the moment. And when we regulate this one, what will industry do then? Will they start using one of the other bisphenols? So the suggestion here is to start regulating substances on a group basis instead, so regulate them as a group instead of one by one. We are far from that now, but that's one suggestion how to solve this problem. So the conclusions regarding the legislation is that there is room for improvements, and with that I would like to go into the last question concerning what type of additional tools that we can use to help to also manage hazardous chemicals. And two examples that has been discussed a lot in Sweden is duty on products that contain chemicals and public procurement. And I am happy to provide you with reports about this, but I'm going to skip going into detail about this because I think I'm running out of time here. But I would like to instead focus on voluntary initiatives, which is what we are here to talk about today. And voluntary initiatives could be like a classification and labeling system, but it could also be like a positive or negative list of substances that could be included or should not be included in certain products. And the problems that we see with the voluntary initiatives are, for example, that goals are set too low, or that the system is dependent on information that doesn't exist, which is a big problem for chemicals, where we lack a lot of information. And also that there is a low compliance among the participating companies. So companies participate, but they don't really follow the recommendations and the rules that are set up within the initiative. But there are ways to ensure that the system is efficient, and I've listed some of the aspects that I think should be considered when evaluating if a voluntary initiative is efficient and credible. And keywords in this process are, of course, transparency and a structure that is logical and clearly defined responsibilities, external evaluation of the process, and also penalties for non-compliance. I have not evaluated TCO development, so I don't know how it would stand in an external evaluation, but what I've seen so far, it's promising. But I will not say anything about these criteria based on that. So the conclusions from my talk today are the following. We don't know enough about the chemicals that we are using. Hazardous chemicals, persistent, bioaccumulative and toxic substances are used in consumer products. Regulating chemicals is a slow and complex process, and additional tools like voluntary initiatives and procurement can be used to reduce use and exposure to hazardous chemicals. I am happy to take questions now, or also you're welcome to email me. Okay.
Thank you so much, Marlene. Very lots to think about. Just a reminder, you can enter your questions in the question field to the right of your screen. And I think we have time for a couple of questions now, Marlene. And there's a couple here that I'm hoping you can help us with. Someone had asked a testing table a few slides back. Maybe we could go back to that slide where we're talking about testing by the ton, and whether that number refers to per factory or per country. There. Is there any kind of
per producer? So in theory, we could have 10 companies that produce just below 1 ton. and they would all go in this category. But if they would join forces, they would go in the other category. So it's per producer or importer.
Okay. Another question here, maybe you could comment on this. There have apparently been studies that show that BPS is just as toxic as BPA. Did you have any comments on that?
Yes, it's what I have read as well, but I haven't read all the studies, so I'm not going to say that it is, but there's an indication that it has similar properties, which is not a surprise. I mean, we see that for a lot of groups of chemicals that they have, when they look the same, they also have similar properties. So it's likely that groups of chemicals act the same in the environment and in our bodies.
Okay. One more question. In general, do you feel that legislation or voluntary initiatives, which is driving progress more? Are we able to see that one is driving change better than the other?
I think both are needed. I can't really say. I think we absolutely need a strong regulation. We need something to like lift the lower bar, but I think it's very important that we have voluntary initiatives that show that it is possible to substitute a substance, or it's possible to produce chemicals that are less toxic or less persistent, and they are still useful in our products and so on. So I think we need both, because there's always going to be companies that are not interested in taking extra steps for the environment or human health. So they need to be regulated by the legislation, and there's going to be companies that can that take the lead and do more than we ask for.
Okay, maybe we have time for one final question. Do we know, or can we make an educated guess about the ratio of, in real life, really dangerous chemicals to not really dangerous chemicals, even if we have only assessed very few of them?
Oh, I don't know if I can guess that, but I think the absolute majority of chemicals are not problematic if they are handled in a good way. So it's the key thing is to have a system that prioritizes chemicals so that we focus our efforts on the really problematic substances. So I'm not saying that we should do really long and complicated and expensive tests on all substances, but we need a process that really finds the chemicals that are really that are of interest to us. But I would say I don't want to make people scared about chemicals, because there's a lot of chemicals that are not problematic for us. But I just hope to contribute to making the process better so we can find the ones that are really problematic.
Thanks, Marlene. Okay, I think we need to move on in the interest of time. We'll have some more time following Nicholas' presentation for more questions, so if you have a question, feel free to enter it in the question field, and we'll be able to get to it towards the end of the webinar today. Thanks again, Marlene. Now we'll move over to Nicholas Riddell, who'll be able to give us an overview of the new non-halogenated substances criterion in TCO certified. Over to you, Nicholas.
Thank you very much. I will go through some of the topics here regarding IT products, because that is what we are focusing on at TCO Development. And we have been seeing and looking at this challenge with chemicals since we started the certification 20 years ago. And we have taken different steps to try to find solutions to this problem. And the last generation of TCO Certified that was released in November last year, we took another big step in this direction. I wanted to talk a little about that. But first of all, just go through some of the background, and some of this Marlene talked about also. Risk, when we do risk assessment in TCO Certified to decide which type of substances we should focus on, we are looking at the hazard and the exposure, and if someone is exposed to a hazard, there is a risk of negative effect. So that is the logic in dealing with substances. And we are looking at the life cycle of IT products, so from the production phase, during the use phase, and in the end of life phase. So we should consider the exposure to these substances during the whole life cycle, and we should also look at the hazards that Marlene talked about. And as she said, there are different types of hazards that are more relevant, like bioaccumulative and persistence and so on. So for IT products, a lot of the substances are sealed in the product during normal use. But the problem is that a very large extent of IT products end up in illegal recycling. United Nations has said that about 90% of the world's electronic waste is dumped in and recycled in a wrong way. And when electronics are burned on the to extract precious metals, for example, a lot of these toxic substances leak out in the fire and in the fumes, and then they fall down like poisonous rain on the vegetables that are grown. And then these toxics are coming back to everyone, and we are eating them. So this is one of the problems. Another problem is that all of the toxics that need to be put inside these IT products, they need to be put there by someone, and those substances must be handled in the manufacturing sites. And some manufacturing sites take this very seriously. They have a lot of protective measures, while other manufacturing sites have less protective measures, and this is also a problem. So by reducing the most hazardous substances, we don't have to consider the exposure to those substances. So these are some examples of toxic content that you find in IT products, and some of these we have handled in TCO Certified the last 20 years. One example is heavy metals, cadmium, mercury, lead, and hexavalent chromium that we banned in TCO Certified many years before they were banned in the RoHS directive in Europe. For example, those substances like lead has been substituted by lead-free alternatives, and the backlight in LCD screens that contain mercury has been substituted with LED backlight. PVC is something that it's a type of plastic that we have banned in TCO Certified many years ago as well, which has been replaced with other plastics. And then also a long time ago we banned halogenated flame retardants, which are used in IT products so that they should not take fire when they become warm inside. And those halogenated flame retardants were substituted with non-halogenated flame retardants. And then some of these non-halogenated flame retardants are also very toxic. they are hormone disruptive and have other negative effects. So the worst of the non-halogenated flame retardants must also be handled in some way, and this is what we have done in the last generation of TC certified, where we are requiring those non-halogenated flame retardants to be assessed, and only the less toxic ones can be used. There are still a lot of toxic substances in IT products, but they must be there for the product to work, and as long as the products are manufactured, used and recycled in a responsible way, there is very little risk that these substances will leak out in the nature. So as we see it now, there is a big challenge with the non-halogenated flame retardants, and the reason for that is that they contain a lot of hazardous substances. They have a lot of hazardous effects, and many of them are unknown. So we decided that they must be assessed before they can be put in TC certified products. We are using an assessment tool called Green Screen for safer chemicals, and this assessment tool is run by an organization called Clean Production Action. I recommend you to look at their webpage. It's an American-based organization, an NGO, and they are a hazard-based assessment method. So they are evaluating the hazard of the substance, not the exposure. What we have put in the criteria for all TCO certified product is that all of those non-halogenated flame retardants that shall be used in a TC certified product must be assessed by this green screen system, which is a fairly fast process compared to other testing of chemicals. And as Marlene said, it's important to try to, in an easy way, identify the worst substances and then deal with them. And this is an attempt to identify the worst ones in an easy way with the green screen system. We say that the assessment that is higher or equal to 2 according to this system will be allowed to be used in TC certified products, but the worst ones that are benchmarked with 1 are not allowed to be used currently. And then we publish all these substances and their benchmark score on a publicly available accepted substance list. And this is like a declaration of what is inside TC certified products. So this is like the content declaration. If you go and shop food in the shop, you can see what's inside there. And this is an attempt to give you some possibility to know which non-halogenated flame retardants that are present in TC certified products. We hope that this list will grow over the years and that it will become useful for everyone using TC certified products, and also the manufacturers who try to produce products with less harmful material inside them. So every substance, every non-halogenated substance that shall be used in the product will be assessed according to the green screen system, and these are the 4 different benchmark scores that you can get on a substance. As you can see, benchmark 4 is the only one where there are only few concerns. So none of them is completely safe, but benchmark 4 is a really good substance. They are very unusual to find benchmark 4s. What we are trying to do is to get less substances with benchmark score U, which is insufficient data. Currently, when we started this program, almost all the non-halogenated substances were unknown to us. And what is happening now for every month, more and more substances are added to the list, and these unspecific data will be known to us. 18 different endpoints of a substance are evaluated, and these are the 18 different risks or hazards. Persistence, bioaccumulation that Marlene talked about, but also cancerogenity, mutagenity, many different aspects of the substance is evaluated. But the evaluation is quite fast to do. And all this evaluation is done by a third-party independent toxicologist who is expert in doing these kind of evaluations. This is how the public list looks like, and all of these substances are accepted to be used in TISA certified product. However, they are still not completely safe. But to be able to construct the product, it is necessary to use these substances. As you can see, if you think back at the example Marlene did with the bisphenol A, in TISA certified, we require all unique substances to be assessed. So if you look back at that example, all of the different bisphenols would need to be assessed if you want to use one of them in TISA certified products. So what do we hope to achieve with this? We want to create more transparency of the content in IT products so that you as a user or buyer can look at our list and see what is inside your product. We want to help to create a shift towards safer alternatives so that manufacturers who want to create more safe IT products can go into our list and look and get alternatives that they can substitute their substances with. And we want to also encourage people and companies to use the green screen system and to use all those toxicologists who are experts in evaluating this to create more information and knowledge about all those substances that are currently unknown. And hopefully by doing this we reduce the toxic content in IT products and also in our food and in the nature. Thank you very much. I'll give the word back to Claire.
Thanks, Nicholas. Great. Okay, I think we have time for a couple of questions that have come in, and I'm thinking maybe we just open this up to both you, Marlene, and to Nicholas, and you can decide who has the answer. We have a first question about complex mixtures of chemicals, and the question is, what is being done to understand human exposure to complex mixtures? Maybe Marlene, that's suited to you.
Yes, I can answer. I know of at least 2 different projects, research projects at the European level that deals with mixture. One is closely connected to EFSA, so it has to do with food a lot. EFSA is the European Food and Safety Authority. And the other one is a EU project which is based here in Sweden at SVHC. It's a research institute that combines the expertise of a lot of 11 different universities here in Sweden. And both of them are focusing on mixed risk effects. But we know a lot about mixtures, I would say, already. So, I mean, there's also, we need knowledge, but we also need a political will to do something about it. We could start using some of the methods that have been developed already in the regulation. So it's not only new knowledge that we need, we also need someone that will take that knowledge and make use of it in the regulatory system. I hope to meet that person someday who does that.
Okay. Another question, I think, Nicholas, this might be suited to you and refers to the figure in the presentation about the 90% of electronic waste being illegally traded or illegally disposed of, maybe is what you presented. Is that figure relevant to the Nordic countries, or is that a global figure? Do you have any reference point there?
That is a global figure. I think the figure is smaller in the Nordics and in Europe also, but it shows the image is similar. I mean, the figure is smaller, but there's still a lot of electronic waste that is shipped illegally to places where it's not recycled in the correct way. There is a trading market where people purchase IT products and ship it out in containers. And this is a problem, because it's a way for these chemicals to leak out of products. If they are recycled in a responsible way, like many products are in the Nordics and also some other parts of the world, then a lot of these dangerous, hazardous materials are taken care of in the process. But the waste contains a value and people can sell it, and there is a big trading business going on the internet where you can buy and sell these type of containers full of scrap electronic waste.
Thanks, Nicholas. One final question. From a practical standpoint, what advice would you give to buyers of products, in this case maybe IT products, as to how they can help reduce the toxic chemical content in the IT products that they buy?
Yeah, I would say that, first of all, do what you can to minimize the content of dangerous substances in the products. Some buyers, they negotiate to have PVC-free cables, for example, or products that are halogen-free. You can have a dialogue with the company you buy the products from and ask them what's inside and how do they deal with the substances that are inside. Do they offer products which are free from halogens and free from PVC and free from phthalates and other substances that are recognized to be harmful? And the second thing is to consider what you do with the products when it's time to get rid of them. Are they recycled in a responsible way? If you sell them on second hand, are you sure that the buyer will recycle them in a responsible way, or will they end up in a container and shipped to Africa?
Thanks, Nicholas. Okay, a couple more questions. I'm not sure if we have time for them today. What I'm going to do is, if you have a question and it hasn't been answered in this session due to lack of time, on the screen is our email address, purchasing@tcodevelopment.com. Please go ahead and email your question to us. We're happy to help you. Also, if you have any questions about TCO Certified or the presentations you've seen today, or advice on how to include some of these sustainability factors when you're buying IT products, we're happy to help with advice and guidance. Also, feel free to connect with us on social media, and also visit our homepage, tcodevelopment.com, where you can find complete criteria for TCO Certified, also a complete registry of all product models that carry the certification. Again, we look forward to seeing you in our March webinar. We'll be making that announcement hopefully early next week, along with sharing the on-demand recording of today's presentation. Many thanks to our presenters today and also to all of you who could join us, and we look forward to seeing you next time. Thank you.